0.1 mile to the west of the second car. So think of that as to the left. The first accelerates, let's see, first accelerates from the standing start at a 0.1 mile to the west of the second car. The second car is traveling at a constant speed of 12 meters per second, of course in the opposite direction. How far does the first car go before the two cars are at the same position? So with problems like this, you always just write down the equation of motion, the equation that gives position as a function of time, in other words, for each car, and then you set the two x's equal. So for the accelerating car, we have, according to what they told us, well, let me first write down the equation for the car with the initial position. So we have x equals 1/2 at squared plus x naught, we'll say. And so that will be just t squared, right? Plus x naught. X naught is 1 mile, so it's 1609 meters. And that's the equation of motion. We'll call it car 1. In other words, it gives the position as a function of time. And then we do the same for car 2. And that one is just, well, you know what? We will draw the coordinate system like this. We'll say the origin is where the accelerating car is over here. And so we'll put the other car, which is going in this direction, at the, we'll give that one the initial position. So x2, he's going minus 12 meters per second, so minus 12t squared plus 1609 meters. So those are the two, as we call them, equations of motion. So now we just set x1 equal to x2, set those two equal, right? Because we want to know the time at this position where the two are adjacent to each other. And so we have, it gives us an equation t squared plus, let's start with the basic equation. It's just going to be equating these. We'll get t squared equals minus 12t plus 1609. Then we can put it all on one side of the equals, and we'll have t squared plus 12t minus 1609 equals 0. And then we can plug it into the quadratic equation, the quadratic formula, and we will get, well, t equals minus 12 plus or minus radical 144 minus 4 times a, which is 1, times c, which is minus 1609, over 2a, which is 2. So we get about 34.5 seconds. We have to use the plus here because if we used a negative, we would get a negative time. So we get the 34.5 seconds. Then we want to know how far the first car goes. So she goes 1/2 the 2 meters per second squared times t squared. So it's 1/2 that 2 meters per second squared times this t of 34.5 seconds squared. And so it becomes 1190 meters. Okay, well, anything on that one? You can check it, plug back into the initial equation. in time, that quadratic equation. And you'll see that the distances add up approximately. Well, okay, anything on that one?
Why did you use the negative 12 again?
Pardon?
The negative 12 for the x.
Oh, because this quadratic formula
Okay.
says x equals, if we're solving the some quadratic equation for x minus b plus or minus, right, square minus 4ac over 2a. So this negative comes from the quadratic formula. The negative you see where it applies here. Well, okay, anything else?